In the last video, I made this fixture to make a part. Now I need to actually make the part that goes with the fixture. I want to set a standard work coordinate system for whenever I use this fixture. So my work coordinate system is going to be on the center line and then the top of the jaw. And that way, whenever I set up this fixture again, I can always just pull that up without needing to retouch it off every time. To find the center, I have a 1/4 inch broken end mill in here, and I'm just going to use my dial test indicator to get that, to find that exact position of the pin. We're dialed into probably about 1 thou right now. I ended up having to set my phone up here on one of my frog pods to be able to see it when it was backwards, and that worked really, really well. Like most of my jobs, this one requires some teeny tiny tools, so of course we need to get run out dialed in. Right now this is really bad, so we need to fix that. We should be good to go ahead and run this part now. Now I can't show you the part again, but I'll give you some more details later as we go. Feels good to be running aluminum again. I've been running stainless for like weeks. This machine just doesn't like stainless as much, and it loves aluminum. So I'm glad to get back to kind of my core competencies on this. This part is for a new customer, but I still can't show the final thing. Here is the roughing done. You can kind of get an idea of the size and scope of what we're working with here. It is definitely a small part. So right now we're drilling some 0.3 millimeter holes. That's 12 thousandths of an inch. This part kind of looks like this. It looks like a heat sink because it's probably a heat sink. And so originally I was going to do this side first and face off the top, and then do this side in soft jaws. The problem is there's some geometry like down here that made the material I had to grab onto for the soft jaws in this orientation really limited. And so after playing with that fixture, I decided to do the op1 in this orientation and do these slots here. Now the challenge is when I flip it and do the top side here, the back side, however you want to think about it, there's not going to be much that I can clamp on. I've got these little fins, but the fins are so thin. So I think I'm just going to have to fill these back in with something like wax, or maybe even hot glue will work in this application. And then obviously I'm not going to clamp like this. I'm going to clamp like from this direction so that it's going along the length of these little fins instead of the width. And we broke that tiny end mill. I can tell it was trying to take a far deeper cut than it should have, and I don't know why. Well, that was dumb. Remember how I was just talking about how I changed around the setup? Well, I had the top height of that tool based on the stock for some reason, and then when I changed the stock, it changed the top height of that tool path, and that put it below the surface of the material. So that was a waste. The part is out. Now we need to remove this giant hat to reduce machining time on the second operation. With some very careful bandsawing, we have most of it removed. Now I'm going to take it to the belt grinder and remove even more of that little hat. I'm setting up my flux vise here, and normally it ships with these spacers. These are kind of a sacrificial shim that you stick in the gaps here for when you, there's already one in there. That you stick in these gaps here when you're cutting your soft jaws, and that way when you're ready to cut your parts, you just take that out and then you have some room to clamp. Now, that's fine for probably 90% of parts, but for my parts, I make teeny tiny things. So these are some 1/16-ish inch shims, and for my stuff, having that gap reduced is definitely beneficial. So I'll be using that on this part because this is so delicate. I put this together backwards. I need to flip it 180 degrees. Let's try that again. Okay, this time with the vise right side around. I have tightened this to what reads as 0 on my torque wrench. It's basically as gently as I can tighten it. I mean, short of, hand twisting the nut or whatever. Now I need to cut my soft jaws. This part is so fragile that I can't use any force to push it down into the soft jaws. So I'm gonna just widen them up a tiny bit, and dial it in to where it takes 0 force to set them down in there. I obviously don't want to be too sloppy or I'll lose my positional tolerance, but I can't risk damaging these things when I put it back into the vise. This is a dumb part. Remind me not to take more parts like this. This thing is just silly. Anyway, now that that's in there, I'm going to use some of this wax. This is from Mighty Bite. Yes, the same people who make the clamps. It has a really nice low melting point. And if I can get it inside the little tines there, I'm not really sure how, but if I can do that, it should stabilize it some during the second op machining. There's probably a better way of doing this than using a spoon, but I can't think of anything. If I heat up the part, one, I don't really want to put heat in this part, but two, the wax will just melt and flow through it. So I'm hoping that if I do a spoonful of hot wax, the part in the cold soft jaws will solidify it, and that'll let me kind of build up a dam, just keep pouring. Well, I'm not convinced that it didn't help, but I'm not convinced that it helped. I guess at this point we just have to run the code. I really hope this works. Let's go to single block. Probably should take this cautiously and go. Alright, let's take it off signal block and go. Well, looks like I was right the first time I programmed this out. That method squished the part and did not work. So I guess I'll see you tomorrow when we make the same part again. So it's the next day, a very snowy day, and we get to do this part again. Yesterday, failed at this part. Today, let's get it right. I just walked in the door as a transition, but actually I have everything set up and ready to run. So I'm gonna hit go, and then I'm gonna tell you about some of the changes I made to hopefully make this attempt a success. Well, I was about to tell you where I went wrong in the past, but we're still going wrong here. My part's gone. My part was supposed to be right there. There was the first attempt, that set of soft jaws. This was the second attempt set of soft jaws, and the part has been ejected. So we're gonna make op 1 again. Fortunately, that's only 10 minutes, and then try this again with some changes to the soft jaws. So the thing that caused me to fail the first time and now just the second time was the same thing both times, and it is work holding. Work holding on this part sucks. It is so tiny and thin, and there's just not anywhere good to grab it, and that's why I keep scrapping it. So the part, like I said before, kind of looks something like this, and it's got like some other features down there. But this down here is only like 20 thousandths thick. These are only, well, they're very small. And so the first way I tried to do it is, while this was all part of a big bar, this is the first time, I machined out all of this stuff here. But then I had to flip it over and try to machine this backside. The problem was, even using a tiny amount of clamping forces, I squished these veins and destroyed them. These walls here, which are a little bit thicker, those even buckled in some, and they were buckled in, and then I milled off, and then when I released them, they kind of, did the opposite. They had a valley in them, and the whole part was very ugly and very destroyed and not usable. So this time, what I am doing, a couple different things. So first of all, I am machining the backside first. So I'm machining it like this first, and then I am flipping it over and machining this side. Now, there's still not very much to hold on here, just 20 thou, like I said before, but it's 20 thou of solidness there, instead of being 20 thou of these veins. So I shouldn't be squishing it, though I'm still having issues where I over tighten it, and I like round over this corner and it pops out. That's what just happened there. But okay, so let's assume I get that dialed in. I'm remaking some soft jaws now, and hopefully we'll have that fixed. But the other problem I had is my finishes here on these veins were really bad. And so what I'm going to do this time is I'm going to do one of these veins, and then I'm going to fill it with wax, and then I'm going to do another one, and then I'm going to fill it with wax. Then I'm going to do another one, and then I'm going to fill it with wax. Hopefully that solves my work holding issues solves the rigidity issues. If I can get past the work holding issues, hopefully that will solve my rigidity issues, and then I can have a good part. The other change I've made is, okay, so I have a plus or minus 5 thou tolerance on all features on this part. I'm going to use some of that tolerance to make those veins a little bit thicker. Those little fins, they are 10 thou thick as designed. I'm going to go a thou thicker in each direction. That way I'm still left with 3 thou where I will be within tolerance. Or I will have 3 thou of tolerance to play with, I should say. And those veins will become 20% thicker. 2 thou doesn't sound like much, but on this part, 2 thou is 20% of the total thickness, which I'm hoping will help, especially when combined with that wax. We got past the dangerous part, the part that had a lot of material removal, and we're still going. The part's still there. So I'm hoping this part will turn out okay this time. If this doesn't work, I really don't know what else to do, except maybe some sort of custom super glue fixture, but like, I'm kind of out of ideas at this point. In retrospect, the way that I would make this part, if I had to make this part again, is I would buy a slitting saw and use the tabbing off method. So I would do all of it, all the slots and everything in op 1. I would cut the features on the side of the part in with the slitting saw and then tap it off. And that way I don't need any second op fixture. All right, we're ready to put the wax in. Like last time, I'm gonna use the heat gun to melt the wax inside a sacrificial spoon. And this time, because I can and I have access to it, I'm going to use some of this powder coating tape to make a little dam to keep the wax from escaping from the little slots, because, you know, we want the wax where it's supposed to be. We are, of course, unfortunately at the point where the part is starting to look like the part and not a Xometry part anymore, but I still can't show you the finished thing. So I guess you get to watch me from this angle as I do it. We're gonna need more wax. I am not making any money on this part. I just broke the tool. When I went to restart it after the wax, well, let me take a step back. When it paused, I put a pause in the program, but it didn't, I didn't give it enough retraction, or it didn't have any retraction on the pause. I'm used to the Tormach, which with the post I have on there, when you give it a pause, an M0 in the code, it will retract the Z all the way up. Well, the Haas doesn't have that in the post, and so it just stopped where it was. So I was like, okay, I can just start the program again. I stopped the program. I moved it up. I put the wax in, and I found where I stopped the program. I restarted it there, and it went too far down in Z and crashed the tool, broke the tool. The part's actually still okay, so I can just leave it where it is and wait for the new tool to come in. However, I don't have a new tool on hand, so I can't finish this up now. Fortunately, when I ordered this, I ordered 2 of them, but they're coming from 2 warehouses, and so a new tool will get here tomorrow. But man, this is frustrating because I keep breaking tools on this job. This wasn't the most high profit job I've ever taken. I really took this job, ironically, because I knew I would use these tools for other things, and so by buying the tools for this job, I'd have them down the line. But I keep breaking them, and so I'm not going to have the tools for down the line, and all I've done is waste money on this job. But yeah, I guess I'm done for now, and we will check back in later in this video. For you guys, it'll be soon, but today's a Saturday for me, and the tool's going to show up on Monday, so I guess I'll see you on Monday. Okay, it is now Monday, and that tool has showed up. The part is running on the mill. I didn't get any video of that because I was just in a rush to get the tool set up and dialed in and making chips. So the UPS in this area doesn't come here until like 6, and FedEx closes at like 7, and there's like 45 minutes of runtime on this part. So I'm cutting this one a little bit close, but hopefully it finishes well and passes inspection, and I can get this out today. This has been, I think, the most stressful part I've ever made. Which is a bummer, because I thought I was taking an easy part. But at this point, I have lost $39 to make this part, plus I've spent, hours of work on it. So, not my best job ever. Okay, just got back from FedEx with 3 minutes to spare. I don't want to cut it that close again, but the part is done and shipped. And at the end of the day, that's what matters.